Hello friends, so in the last video we saw that computer understands only 0 and 1, like we understands only 0 to 9, only 10 symbols, because we have 10 fingers in our hand and it was very easy to calculate in the early days. And there are some other civilization, they used to count their leg fingers also, so they used to have 20 symbols. But coming to us, we are using the decimal number system, which has only 10 symbols 0 to 9, and we keep reusing them. And then we also learned that binary, the computer who understands 0 and 1 is called binary number system, where he can only understand 0 and 1, and then after 1 they have to repeat the symbol. It will be 0 1 and then it will be 1 0, and that 1 0 is not our 10, it's their our 2 and their 10. So that's how it is. And then we realized that how can we send alphabets, and then we realized, okay, there is a way to map or represent the alphabet seeing a chart that the whole world has agreed. It's called American Standard Code of Information Interchange, ASCII, and that's where we mention A equal to 1 0 0 0 0 5 zeros 1. So that's the everyone agreed that let's represent A as a 1 and then 5 not 5 zeros and then 1. That's the symbol of A. And then we decided to send the symbol A to computer and see if it can recognize by this number. So this much we have learned last class, and now we are going to see how can we generate that 1 or 0 means the 5 volt and 0 volt, and then we will slowly progress on how to send it to the computer. So let's start. So I will be using PictoBlox for this purpose, and this is the device I have with me. Let me zoom if it can. Yeah, so this is called Arduino Uno, very popular device. Everybody, if they know computer, microcontroller, probably Arduino is the one at least they would know. So yeah, so this Arduino, I want to plug it to my computer. I already plugged in, and then I go to PictoBlox board and choose Arduino Uno out of all this controller that PictoBlox supports. So I will click Arduino Uno, and then it's looking for all the ports that I have, all the addresses, all the devices that I have connected to my computer, like my mouse, keyboard and many other things. But I have to find out that particular address which belongs to my Arduino. I know it is wch.cn, so it's COM5. I will connect to that, and you see there is a blink happened. That means it's connected. And now what we will do is we are going to write a code to blink the LED. So the LED is already blinking for some reason, and let's flush the code out. Let's clean the code. So what we can do first of all is, first we'll upload a firmware. So this is how the PictoBlox communicates with Arduino. So once this firmware is inside Arduino, then it will be able to communicate with the device using block coding. That's the idea. So we are not bothered about that right now. We want to send a 0 and 1 and see the LED glowing. That's what we want. So when it should glow, that's called event. So we have to choose an event. We can say glow, but when to glow, that we have to say. So we say when I click this green button, it will glow. That's it, leave it. So now, because I connected Arduino Uno, I got this block of code where I see set digital pin, and if I connect this, and the pin I have connected here, there are multiple pins and they have some numbers. So I have connected the LED with the pin number 2. So I have to mention here pin number 2 is connected, and can you please send, let me switch off first, this is on, right? So I want to click this flag and it's off. That means I am sending signal low, means 0. Now I want to send a signal high, so make it high, and then click the flag again, and it's on with the brightest glow. Okay, so now let me switch it off for the moment because I don't want to heat it up. But okay, so now what I'm going to send. I want to send A means 1501. So let's try writing it. So first I will say digital pin 1 means high, and then I will duplicate it as many times I want. I just duplicate 1, 2, 3, 4. I have to duplicate 7 times, and actually 8 times. I can keep a 0 at the beginning. So 0 at the beginning has no meaning, right? So no value. So I just keep a 0 because I want to make it a 8-bit. Why? Just forget for now. So this one high, low. So 5 not 5 low. 1, 2, 3, 4, 5. So you see, forget about this low. Start from here. 1, 0, 0, 0, 0, 0. How many? 1, 2, 3, 4, 5. 5 zeros and then 1. So let's try. 1. Then what happened? It's on for a long time. Why? So what happened, you know? Computer is so fast that it executed all this within a second, and you didn't really see what happened. It happened in a moment. So what I have to do, I have to introduce delay to really see what's happening. So I will add a wait of half a second in middle of each of these signals so that you can see it coming. And then I'll duplicate this, duplicate this, duplicate this, and finally one more, because okay, not needed right now because we are not running it in a continuous loop, but yeah, I'm just keeping it, just it looks beautiful, that's why. So now I'll click the green flag and just notice it will be off, then on, everything for half a second. Okay, so let's count. Okay, yeah, off, 1, 0, 0, 0, 0, 0, 1. Now I have sent this. I can send this signal to PictoBlox or some other device and ask him, did you receive a? Because I just now sent you a because this is the ASCII code of A. But will it realize, will it understand that I have sent a by glowing the signal on and off? So what I'm saying, from this point, from this pin, the signal of A is originating, and I can take this pin and feed it into some other device and ask him, can you read what I'm sending to you? So that's the idea, but it's not going to work. Before even I can try, I'm saying it's not going to work. And why it will not work, let's see. So this is how the alphabet A will look like, right? First 1, then 4 not, 4 zeros, and then 1. And if you plot it, this one being the 0 volt and this one being the first 5 volt, then it will be 5 volt and then it will be 0 for a long period of time, and then it will be again back to 5 volt and then back to 0. That's what A means, right? And then the question is, why computer will not understand if I just simply send it? The reason is there are 2 points. Point number 1, computer have to be aware of you are sending something to him. He is not always listening to you to save some battery, save some power, and many reasons. So you have to first of all tell him that I am going to send you a data. That too is a signal. So you have to add a signal before it to tell somehow I am going to send you something. What is that something? He will slowly understand after reading bit by bit. And at the end, once you done transferring the signal, you have to send another bit, extra bit, to say that I am done. So that's what you have to do. And another challenge number 2 is, when you send continuously 0, then how computer will count how many zeros you are sending? Suppose if it mistakenly counts only 4 0, then it will be 1 0 0 0 0 4, and missing 1 0 means it's entirely a different character. It is not capital A, it will be something else from the ASCII table. So that's again a disaster. So you need to understand how can we send and tell the computer that we are really sending a 50 and not 40? How to tell that? So if it is only 101010, it's very easy. The computer will see the voltage is going up and down, and every time it's going up it will count 1 and down 0, and it will just keep writing 1010 and it will find out. But that's not always the case, and that's where you need to be very precise about what a single bit, how long a single bit goes on. I mean, you have to define that. It have to be very precise. You have to precisely tell that any bit will last this much millisecond. So you have to be like in our PictoBlocks video, we saw that half a second we keep the bits on. So for that case, you have to tell computer that each bit will be available for half a second. So if you see continuous 1 2 3 4 means 2 seconds and half, so 2.5. So if you see 2.5 seconds the light is off, that means each half second is 1 bit. So that means 2.5 by half means 5. There are 5 zeros. So that's how computer is going to find out. But we have to be in an agreement. What is the delay we are giving? Half second, 1/4 second, how much millisecond, nanosecond, whatever we are doing, we have to agree. Ourselves and the computer both have to agree on a number, how long we should give the delay. You cannot just randomly decide a number. So once you do that, these two things you take care, and computer will understand what you are sending. And that is what we are coming to, and this is our main focus going to be in the upcoming videos, and which is UART. So we are going to talk about UART communication, which is a serial communication. What is serial? You can see the previous videos. We will understand what is serial communication and what is parallel. And for serial communication, UART is one of them, and this is how it works. So as I told you, at the beginning you have to send a start bit that will tell that be ready, I'm going to send something, and at the end you have to send an end bit. So the start and end bit you have to take care, and rest of the thing, the timing, you have to take care. And if you take care of all this, then finally computer will realize you're sending A to him, and we are going to see it live. So keep watching. Thank you so much.